So one of the topics that we cover in this class is optimization, making a program faster but having it compute the same result. And I like optimization a lot. It is a lot of fun to think of cool ways to speed up the code. But it turns out that often getting the right answer or maintaining the code later, having the code be well documented, making it easy to debug the code, these things might all trump optimization. Steve, have you seen anything like that at Mozilla or other projects you've worked on?
Oh, constantly. Within the SpiderMonkey JavaScript engine these days, I kind of feel like we spend half of our time removing old optimizations to make way for refactorings, future engines. I think we've been hit particularly hard because we've switched our JIT engines several times at this point. TraceMonkey was our original optimization, well, our original JIT engine, which had a particular style of optimization that it covered, and we have since entirely removed the TraceMonkey JIT engine and replaced it with JagerMonkey, which is kind of the next generation JIT engine, except now it's the previous generation JIT engine itself, and it is slated to be replaced by IonMonkey. We like monkeys.
That's a recurring monkey theme.
Yes. And it turns out that the sorts of optimizations that are really helpful for a tracing style JIT are really obnoxious when you get into a different style of JIT, because they just get in the way, and it prevents you from making a lot of the code simplifications that makes it straightforward to do a JIT in a different style. And so there are many, many different optimizations that we've had to just rip out wholesale. And unfortunately, it's at least as much work to remove some of these optimizations as it was to make them in the first place. And really, anytime you do an optimizations, you have to be very aware of the cost of that optimization. You may be saving some runtime, but you are adding complexity to everybody who comes by and tries to read and understand that code. You are preventing some refactorings, some restructurings of that code, because it would break the optimization. The optimization was made with certain assumptions. That's almost the definition of an optimization, is that if we assume certain things, then we don't have to do some of these operations. And that's the way to make things faster, is to not do some of the things that you were previously doing. And so there are all kinds of hidden costs to an optimization, and it can actually be very damaging to put certain optimizations in the code, because they're going to prevent other optimizations, that are going to prevent simplifications of the code. They're going to prevent changing the semantics of what you've implemented, because the optimization bakes in certain assumptions that you may want to change in the future. And so we spend a lot of time trying to find the right balance today, which is actually different from the balance yesterday. And so even if the previous optimization made total sense in the past world, it may actually get in the way in the current world. So yeah, we see a lot of this.
Excellent. Now, you mentioned something that caught my ear, and I wonder if I might put you on the spot with a bit of a surprise question. You mentioned that you're looking over old code or refactoring it. And I'm just wondering, throughout your average day, let's say you spend some amount of time reading code and some amount of time writing new code. What's that ratio? Or how many hours is fixing bugs in code, looking over old code, and how much is writing new code?
It varies a lot from day to day. Some days are actually spent 100% writing new code, and those days are happy days and rare days. The vast majority really is looking at existing code. Sometimes code that I wrote, much more often code that other people wrote. And here at Mozilla, we have a rule that every line of code that goes into the tree must be reviewed by another person. So, in terms of, you have a ceiling of 50% of time is spent on new code, because every line of new code is going to be viewed by at least one other person. And often you'll go through multiple rounds of review, and so multiple people or the same person are looking at that line of code several times. But even if you're going to write new code, you always have to understand the context in which you're placing that code. And so you really have to understand what comes before, and you will spend much of your time doing that, far more of your time doing that than kind of going into a green field and putting something brand new in place.
And this idea that you have to understand the context in which you're adding code is one of the reasons why understanding the meanings of programs, their semantics, is so important.